Hello students. So we start with the first chapter of organic chemistry, that is haloalkanes and haloarenes. Haloalkanes in common nomenclature are called alkyl halides and haloarenes are called aryl halides. So we can say haloalkanes and haloarenes, or we can say alkyl halides and aryl halides. See, those organic compounds which contain carbon, hydrogen and halogen, they're called halogen derivatives of hydrocarbons. Halogen derivatives of hydrocarbons. And some of these compounds, they exist in nature. Many of them are man-made, that is artificial compounds. Many of these compounds, halogen containing organic compounds, they are used in agriculture and in healthcare, medicine, etc. They're also used in the manufacture of many other type of compounds. Some of these examples, which are a part of your NCERT book, you must remember. I'll give you these examples. First example is a compound called chloromycetin. Chloromycetin is also called chloramphenicol. This is a chlorine containing organic compound called chloromycetin or chloramphenicol. This is produced by soil bacteria and this is used to treat typhoid fever. Second example is thyroxine, Thyroxine. You might have heard of it. Thyroxine is a iodine containing hormone produced in our body. Its deficiency leads to the disease called goiter. Okay? You might be knowing about it. Then a chlorine containing compound, chloroquine. This is used for the treatment of malaria. There's a compound called halothane. Halothane. Molecular formula of this compound, halothane, is CF3CHClBr. This compound is used as an anesthetic agent during surgery. Then you might have heard of DDT, dichlorodirphenyl trichloroethane. DDT is used as insecticide. We'll study about this compound a little in detail towards the end of this chapter. DDT is used as insecticide and BHC, benzene hexachloride, is used as pesticide. And last example, you should remember that some fully fluorinated compounds, fully fluorinated means all hydrogen atoms of hydrocarbon are replaced by fluorine atoms. Some fully fluorinated compounds, they are being considered as a substitute for blood during surgery. Now coming to classification of halogen containing compounds. One or two classifications are very easy. Nothing is generally asked in exams. First classification is that on the basis of type of halogen present in the molecule, they may be classified into chloro compounds, bromo, iodo, or fluoro compounds. Right? If bromine is present, then bromo compound. Second classification is based on the number of halogen atoms present in the molecule. If there are 2 chlorine atoms present, we call it dihaloderivative. If there are 5 bromine atoms present in the molecule, we'll call it pentahalogen derivative, right? So depending on number of halogen atoms present in the molecule, these halogen atoms may be same, may be different, but total number of halogen atoms, on that basis, we classify them into dihalo, trihalo, monohalo, pentahalo derivatives. And remember, if all hydrogen atoms of alkane are replaced by halogen atoms, then the compound is called a perhaloalkane. Perhaloalkane. I talk about a very simple compound, CCl4. CCl4 is carbon tetrachloride. Generally, the common name uses tetrachloride or carbon tetrachloride. Another common name on this basis, we can also call it perchloromethane. All hydrogen atoms of methane are replaced by chlorine atoms. So CCl4 can also be called as perchloromethane. That is another common name of this compound. Now, third classification is based on the type of hydrocarbon from which these organic halides are derived. If um, the halide is derived from alkane, we call it alkyl halide. If organic halide is derived from alkene, we call it alkynyl halide. If it is derived from an alkyne, then we call it alkynyl halide. And similarly, if it is derived from an aromatic hydrocarbon like benzene, then we call them aryl halides. Now coming to some important type of classification. So fourth classification is based on the type of hybridization state of carbon to which halogen is attached. I'll repeat, fourth classification is based on the hybridization state of carbon atom to which halogen atom is attached. And this classification is only for monohalogen derivatives. Only one halogen atom should be present. Now this will take in two parts. First part will be compounds in which halogen is attached to sp3 hybridized carbon atom. First of all, I think you should be aware of how do we find out state of hybridization of carbon atom in the molecule. If carbon atom is if carbon atom is forming 4 single bonds, it is sp3 hybridized. If carbon atom is forming 1 double bond and 2 single bonds, it is sp2 hybridized. If carbon atom is forming 1 triple bond or it is forming 2 double bonds, then carbon atom is sp hybridized. So in this classification, in A part of classification, I'm considering compounds in which halogen is bonded to sp3 hybridized carbon atom. This category of organic halides, they are further divided into 4 categories. First category will be alkyl halides or haloalkanes. In these compounds, halogen is attached to sp3 hybridized carbon atom of a saturated open chain. Saturated, all bonds are single bonds between carbon atoms. Open chain means there should be no ring of carbon atoms. So I'll repeat, alkyl halides are those in which halogen is attached to sp3 hybridized carbon atom of a saturated open chain, which is called alkyl chain. Their general formula will be CnH2n plus 1 X, or we also call it Rx. This part in the circle is represented as R, that is alkyl group. So if N is 2, it will be C2H5, C2H5Cl, C2H5Br, like this. They are further classified into primary, secondary, and tertiary alkyl halides depending on the carbon to which halogen is attached. Now, what are primary, secondary, and tertiary carbon atoms? Remember, that carbon which is directly bonded to one more carbon is primary carbon. That carbon which is directly bonded to 2 more carbon atoms is secondary. Directly bonded to 3 more, tertiary. Similarly, directly bonded to 4 more carbon atoms will be called a quaternary carbon atom. I'll give an example for that. This carbon is primary, directly bonded to 1 more. This is primary. This is quaternary, primary. This is secondary. This is tertiary, bonded to 3. This is primary. This is primary. Now you can see quaternary carbon is already attached to 4 neighboring carbon atoms. This cannot be bonded to any halogen atom. So if halogen is attached to a primary carbon atom, we call it primary alkyl halide. Similarly, secondary or tertiary alkyl halide. So I can say this is secondary alkyl halide. Halogen is attached to a secondary carbon atom. This is primary alkyl halide. Halogen is attached to a primary carbon atom. This is tertiary alkyl halide. So first category was alkyl halides. Second category is cycloalkyl halides, or they're also called halocycloalkanes. Now, in these compounds, halogen is directly bonded to sp3 hybridized carbon atom of a saturated alicyclic or carbocyclic ring. Alicyclic or carbocyclic ring is that in which all the atoms forming the ring are carbon atoms, right? So cycloalkyl halides are those in which halogen is directly attached to the carbon atom of a saturated alicyclic or carbocyclic ring. Their general formula is CnH2n minus 1 X, and they can further be classified into primary, they can further be classified into secondary or tertiary. They cannot be primary. For example, this is secondary cycloalkyl halide. This represents methyl group. So this is tertiary carbon atom to which bromine is attached. This is tertiary cycloalkyl halide. Now, third category under sp3 hybridized. Third category is allylic halides. Very important category. Now, allylic halides are those in which halogen is bonded to an allylic carbon atom. Now, what is allylic carbon atom? Remember, allylic carbon atom is that sp3 hybridized carbon atom which is attached to carbon-carbon double bond. I'll give an example. These are carbon-carbon, two atoms of double bond, sp3, sp3, sp3. These three are allylic carbon atoms, right? So if halogen is directly bonded to allylic carbon atom, it will be called allylic halide. They can be further classified into primary, secondary, and tertiary allylic halides. For example, in this case, if halogen is attached here, this will be secondary allylic halide. You have to carefully see this is allylic carbon and this is secondary carbon. So this is secondary allylic halide. This is primary allylic halide. This is tertiary allylic halide. In this case, there are two allylic carbon atoms, 1 and 2, and both are secondary. So if I attach halogen here, this will be secondary allylic halide. And if I attach methyl group here, this will be tertiary allylic halide. So I'll repeat, if halogen is bonded to sp3 hybridized carbon atom, I told you there are further 4 categories. I told you about alkyl halides. Number 2, I told you about cycloalkyl halides. Third, I told you about allylic halides. Now coming to last, that is 4th category, is benzylic halides. Now, benzylic halides are those in which halogen is bonded to benzylic carbon atom. Now, what is benzylic carbon atom? Benzylic carbon is that sp3 hybridized carbon atom which is directly bonded to benzene ring. For example, this is not benzylic carbon atom because the ring is not benzene ring. This is benzene ring, but this is still not benzylic carbon atom because this is not sp3 hybridized. Now this is benzylic carbon atom, right? So sp3 hybridized carbon atom directly bonded to benzene ring, aromatic ring, that is called benzylic carbon atom. And if halogen is attached to benzylic carbon atom, this will be called benzylic halide. And they can be primary or secondary or tertiary. For example, this is primary benzylic halide. This is secondary benzylic halide. This is tertiary benzylic halide. Benzene ring directly bonded to benzene ring. This carbon and this carbon, these are two sp3 hybridized carbon atoms, which are allylic carbon atom. Benzylic carbon atoms. So this is secondary benzylic halide, right? This is secondary benzylic halide, and this becomes tertiary benzylic halide. So these were four categories in which halogen is bonded to sp3 hybridized carbon atom. Now, based on type of hybridization, second category is when halogen is attached to sp2 hybridized carbon atom, right? So second category, compounds containing bond between halogen and sp2 hybridized carbon atom. In this category, there are further two divisions, two categories. One is aryl halides. Aryl halides are also called haloarenes. In these cases, halogen is directly attached to the aromatic ring, which is sp2 hybridized carbon atom. And they're always secondary. Right? Halogen directly attached to aromatic ring, that is benzene ring. And this carbon atom to which halogen is bonded, this is sp2 hybridized. So this is secondary aryl halide. Again, secondary aryl halide, right? Second category is vinylic halides. Now, what are vinylic halides? Vinylic halides are those in which halogen is attached to the carbon atom of C double bond C. And these two carbon atoms of C double bond C, they are called vinylic carbon atoms. And they can further be classified into primary and secondary. They cannot be tertiary. For example, first of all, these two are vinylic carbon atoms, right? If halogen is attached to this vinylic carbon is a secondary carbon atom. So this is secondary vinylic halide. This is primary vinylic halide because these are two vinylic carbon atoms and halogen is bonded to primary vinylic carbon atom. This is primary vinylic halide. This is secondary vinylic halide, right? So that was about classification of organic halides.